In the last video, we touched on counting. We said that we could have nothing, and then we could have something, and then if we change that in the same way that we changed from nothing to something, if we change it again in that same way, then, well, that establishes the basis of counting. So, to recap that, or to re-explain it, we have nothing, we have something, and then we have another something that's different than the first something in the same way that the first something is different than nothing. We're starting to get complicated, so instead, we're going to label them. If we have nothing, well, we have 0. That's nothing. That's the basis that I keep referring to. So we have nothing right there. Then, if we have something, we have just that one something. If we change it again, then we get the number 2, mostly just because we've decided that the number 2 represents this. We have this something, and then we change it again in that same way. If we change this in the same way, then we have 3, and I'll do one more just so that way we have a strong pattern established. We have the 3, and then we add on one more. Now we have counting, and there's so much we could do with that. So we can't dive too deeply into what counting is, or what counting can be used for, but this is what counting is. We are changing something in the same way every single time, and then we're labeling it, so that way, instead of saying something different than nothing, which is different in the same way, and then you get your tongue twisting, we just have 0, which is nothing, 1, which is our something, and then 2, 3, 4. And we can keep going on like that. We can keep adding one more on forever? I think so. So we could have 5, and we could have 6 and 7 and 8 and 9 and 10. Now, I also want to note what counting is. We have nothing, and then we have something. And we're just doing the comparison of something to nothing. We discussed that in the last video. These are all the same, but I could easily come along and replace this here. Well, I had changed this. That blue block is different, right? Remember, all we're doing is comparing something to nothing. That's why this idea was so important. I can still say I have 3 blocks here, even though one of them is blue. If I'm only saying that the comparison, what I'm comparing, the information that matters, is that there's a block there, not the color. If I was comparing the color, then these two things would not be equal. So if I had these and these, if I was comparing if these are exactly alike with all possible metrics of measurement, well, they're not the same because this blue one is different. But if I'm just saying the number of blocks, the way they differ from nothing, and I'm comparing that, well, then these are the same. You could have 3 blocks and 3 blocks. So counting is really useful because that means you can count anything, really. Anything that has a distinct amount. Now, if you are saying, if you're trying to compare one handful, these are both one handful. One handful doesn't really define anything. It's hard to say what one handful is. Yeah, one handful is different than nothing, but what is one handful? I can say that this is, and I can say that this is. Now, clearly, if I compare the two, they're different. So counting only works really well if you have a defined object. If it's something that can't be split up. Another thing that we're going to be able to do with counting is we're going to be able to say that even though these aren't the same, we could say they're the same and say that this is 1 and then this is 2. However, there's something useful we can do with the fact that they're different, and that way I can tell these two are different, is I can say that this is 1 and this is 2, and I can say that this is 3, but I can say that this doesn't make 4. Instead, I can say that this block, which I can tell is different because it's green, represents this many orange blocks. That this is the same as this. It's not, but I can say it is. I can say that this one green block differs from nothing in the same way that these 10 orange blocks differ from nothing. So that way, these are the same. These aren't the same. If I add one in, these aren't the same. That this one is exactly equal to, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. So that way these are the same. Now, anywhere where I need 10 blocks, instead of having all 10, I can just have that one green block. Well, now, with counting, we've unlocked counting places. Similarly, instead of this blue being equal, I could say that this one blue represents 10 of these green. Well, then I have my hundreds place. So I would have ones place, tens place, a hundreds place. I could have a thousands place. And I could keep going on. All I'm doing is saying that each one represents 10 of the previous. So this represents 1,000 orange blocks. So this represents 1,000 of something different than nothing. And I can now create actual numbers, so take a guess at what that would be. Well, we would have 1,324. I'm able to represent any number I want now. Before, just a few minutes ago, we were just discovering 1, 2, and 3. And now I can quite easily, with only a handful of blocks, represent a big number, more than I can count on my fingers. It'll take me several minutes to count that one by one by one. We're getting a little bit more powerful with this idea. We're seeing that we're able to represent items of a set now that are too big to represent directly. I don't have 1,000 blocks, but I can express that idea to you. This counting, I think, is going to be very, very useful.